Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about some basic morphological algorithms. So, what are the basic morphological algorithms and how these are related to the image processing? So, in many areas of knowledge, morphology deals with form and structure of biology and social studies, etc. But in the mathematical morphology deals with set theory. Sets in mathematical morphology represents objects in an image. So when we are going for the morphology, it is about the image. When it is the mathematical morphology. When it is a mathematical morphology, it is about the image representation. But when we are going for the morphology, it represents the deals with the biology and social studies. So that is the reason we are completely discussing about mathematical morphology. So in the mathematical morphology, it is used to extract image components that are useful in the representation and description of region shape, such as boundaries, extraction, skeletons, convex hull, morphological filtering, thinning, pruning. So mathematical morphology especially are using for image processing, or image compressions or data compressions. So that mathematical morphology used to extract image components that are useful in the representation and description of region shape, such as boundaries, extraction, skeletons, convex hull. In the Italian word, it is the envelope convesso. It is a Italian word. And the morphological filtering. When we are using filtering, reduce the noise. And thinning and pruning. So these are the extracting the steps of mathematical morphology. So mathematical framework is used for why it is need for mathematical framework is nothing but a image or data compressions or data image or data restorations. Image or data compression, image or data restoration, mathematical frameworks are used. So first one is a pre-processing. In that pre-processing, what are the sub points are there? Noise filtering, shape simplification. Okay, pre-processing is nothing but a noise filtering. Okay, remove the noise and shape simplification, borders and edges. Okay, these are the shape simplification. And the second one is a enhancing object structure. What are the sub things are there for enhancing the object? Means skeletonization and convex hull. So these are under enhancing. And the third one is a segmentation, watershed example. And quantitative description. What are the means? Area, perimeters are the quantitative descriptions. So main things are the mathematical frameworks are pre-processing, enhancing object structure, segmentation, quantitative descriptions are the major things of mathematical frameworks. So set in mathematical morphology represents objects in an image. So when I am taking the image, it is in the form of only binary things. Binary. That means 0 or 1. So the mathematical morphology represents the object in the image as a binary representation. In the binary representation, the binary image 0 equal to white, 1 equal to black. So the element of the set is the coordinates of x comma y of pixel belong to the object as minus z2. So when I'm going for the grayscale image, the element of the set is the coordinates of x comma y of pixel belong to the object and the gray level of z2. So here I'm taking z2 and z3. So what about the z2 and z3? We will discuss. So z2 is completely binary image and z3 is about grayscale image. So binary image is nothing but a zeros and ones. If the image is completely white, that is 0. If in the image in the form of black, that is 1. So the element of the set is coordinates are x comma y of pixel belong to the object as z2. When I am going for the z3 scale, the grayscale image, the element of the set is the coordinates of x comma y of pixel belonging to the object and the gray levels. So if I am taking it is a x axis and it is a y axis, so these are the grayscale or pixel images. These are the pixel images. So these are the different things are there. That one is a binaries and grayscale images. So what are the basic set operators? So these are the major things are using in morphological algorithms. So the basic set operators. What are the basic set operators? First one is a set operator and denotions. So if I am going for the A subset B, the symbol is like this, and the union of A B C equal to A union B, intersection of A and B C equal to A intersection B, and disjoint function and complement of A and differences of A and B, that is a minus B, reflection of A, that is a this one, translation of A set to B, that is a AZ. So these are the set operators and denotions. So what is the need of this one means we are using in morphology, image morphology algorithms. So next later we'll discuss like this, what are the set operations and denotions, what is the need of morphological images, we'll discuss later. It is one example of two sets A and B. It is a set A and it is a B. There are the different sizes are there, and figure A, two sets A and B, and figure B is the union of A and B. So what is the union of B, A and B? A union B. Symbolically we are showing as a, it is the A. So in the A, it is A and it is B. So in the A, B is also union. Okay, here intersection, two sets of A and B. Here third one is the intersection of A and B. Here the intersection of A and B. Here it is A, but B also intersected. Here only A is there, only A. There is no B. But here the difference between A and B. What is the difference of A and B? Okay, so A intersection, A difference between A union and A intersection and two sets of A. So it is one example of set operators and denotions. And another reflection and translations are, if I am taking the B equal to W of E2, W equal to minus B2 plus B for B tends to capital B. A of Z equal to C tends to E2, C equal to A plus Z for A tends to A. So here I am taking A union B. So here A intersection A, here A or B, here I am taking B. So it is a intersection, it is a B intersection. So if I am taking the intersections, graphically I am taking as a Z1 and Z2. So it is a reflection and translation of B. It is one example. And here there are the logical operations with A and B. Okay, logical operations I am using with intersections of A and B. So here A. What about A means? If I need a NOT gate, what I have to do? NOT means exactly opposite. So that means this blackish is converting to the white, this background white is converting to the black. Why? Because NOT means complement. So A means completely opposite. Background is white, here black. It is black and it is white. Here it is black, it is white. Okay. And A and B. here it is A and here it is B. A and B. Okay. What is a common thing of A and B? That is a common thing. And here it is A and B. A or B. Because what are the, if I am joining this one, what is the shape? If I am joining both of this one, what is this mean? So joining is black color, disjoining is a white color. X or B. Okay, X or B means it is exactly opposite. Why? Because here what are the blackish is there, in this black I am replacing with white. Okay, what is the disjoint of this one? Not and means what are the only B is there, I am taking that one only. Remaining A I am taking as a white. It is a not and. For exactly opposite, not and. So what is the, here black is there, here background is white, here it is a black and this one is a white. Okay, not A. So these are the logical operators with morphological operators A and B. Another one is a major thing is a structural element, SE. So what is the structural element? The small set to probe the image under study. For each SE, define the origin. The shape and size must be adapted to geometric properties of the object. So, structuring element. Suppose I'm taking it is A and it is B. Okay, this middle point is the intersection of A and B. It is the intersection of A and B. So, this I am calling as a structural element. So, what are the touching points? What are the common points of A and B? So, it is a common point. It is a touching point of A and B. This is I am calling as a to B. That is a structural element. And it is the midpoint. So, it is only 3 by 3 matrix is there. What is the midpoint here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, which one is the mid one? 1, 2, 3, 4, 1, 2, 3, 4. So, it is a midpoint. It is a structural element. Suppose I am taking 4 by 4. So here 2 rows are there, here 2 rows are there. So maybe the midpoint is like this. Okay. So it is a structural element. So here it is a structural element. Here it is a structural element. So I am taking here, it is here. So what is the common thing here? In the row it is a midpoint, and in the column it is a midpoint. So it is called a structural element. Here also, what is a midpoint here? It is a structural element. So here also, what is here means the midpoint is a structural element. Okay, the structural element is nothing but a small set to probe the image under study. For each SE, define the origin. Shape and size must be adapted to geometric properties for the objects. What is the basic idea about the morphological algorithms? So in parallel, for each pixel in binary image, check if SE is satisfied segment. So structural element is satisfied or not. In parallel, for each pixel of binary, check structural element is satisfied. Output pixel is set to 0 or 1 depending on used for operation. Okay, what is the basic idea about the structural element? So when I am going for the in parallel of each pixel in binary image, check structural element is satisfied. Output pixel is set to 0 or 1 depending on used operation. Okay, so if I am going for like this, okay, these are the different colors are there. These pixels in output image check in structural element will be fit. Okay, it is a basic idea about the structural element. How to describe the structural element? It can be described in many different ways. First one is a information needed. So how can be described? First information is needed. How information is needed? How we get in means the position of the origin of SE is important and the position of the elements of belonging to the SE. So these are the two things. Position of origin for SE, position of elements belonging to SE, structural element. These are the describing of SE. And these are some examples of line segment, it is a two different colors are there. The middle point is there, the SE, but here it is called line segment. Here line segment, the middle one is a SE, origin is not in SE, but here line segments are there or not in SE. Okay, the middle one it is a SE. So pair of points separated by 1 pixel. Here the middle one is a SE. So these are the different segments are there. So what are the different structural elements are there? This line segment with the origin, and the line segment is not in SE. Pair of points separated by 1 pixel. So these are all under structural element SE. So everything we are underlined here. What is the middle point here? It is a structural element in the line segment. If I am going for the line segment of this origin, it is a SE. Okay, these lines are line segments. It is a middle one. If I am taking the 3x3 matrix, what is the middle one? It is a segment SE. Okay, so this is the structural element. So major things, what are the morphological algorithms? The 5 binary morphological operations are, these are the very, very important 5 binary morphological operations. Binary means in the form of 0 or 1 only. So erosion, dilation, opening, closing, heat or mist transform. These are the very, very, very important binary morphological operations. First one is a erosion, dilation, opening, closing, hit or mist transform. Okay, these are the 5 binary morphological operations. Each one will discuss in the next hours, but now I am discussing briefly about erosion, dilation. So if I am going for the erosion, you have to see like this, increasing to decreasing of the lines. Here dilation means decreasing to increasing of the lines, and combining to opening and closing. Opening means object. When the object is called, that is opening. When the background is called, that is a closing. Suppose so, what is the object here? It is the object. What is the background here? The completely, these are the all backgrounds. This object I am calling as a opening. This background I am calling as a closing. So we are keeping the general shapes, but smooth with respect to smoothing and sharpening also applicable for this opening and closing. So what are the major things of binary morphological algorithms means? Erosion, dilation, opening and closing. So opening and closing are under combining. We are combining the two images. Okay. Suppose this object is there, background is also important. Suppose this background is there, without background, what is the need? I need an object also. Object is also important. So both object and backgrounds are very, very important. That is the reason we are combining opening and closing, object and background. So object is important, background is also important. That is called combining of opening and closing. So these are under all basic binary morphological algorithms. These are the references. So in the morphological means the biology or social studies are the many knowledge of morphology, but the mathematical morphology deals with set theory, sets in mathematical morphology, reference objects in the image. That is a mathematical morphology. So in the mathematical morphology, we are extracting the image components that are useful in the representation and the description of region of shape, such as boundaries extraction, skeletons, convex hull, morphological filtering, thinning, pruning. So these are the mathematical morphological types. And what are the mathematical frameworks are used? Pre-processing, noise filtering, shape simplification, enhancing object structure, skeletonization, convex hull, segmentation, watershed, quantitative description, area parameters. These are the mathematical frameworks. So if I am taking the any of the image, the mathematical morphology is important because prepare algorithms with mathematical morphology. So what are the frameworks means? Pre-processing, noise filtering, shape simplification, enhancing object structure, skeletonization, segmentation, quantitative description, area or perimeters are the mathematical frameworks. So in the mathematical morphology representations are two types: binary image representation, grayscale image representation. Binary means only two, 0 or 1. 0 is a white and 1 is a black. These are the elements of set of coordinates or x comma y, or the pixels belong to the Z2. Grayscale means it is a Z3. That means the element of the set is the coordinates of x comma y of pixel belonging to the object and the gray levels. And what are the basic set operations? The set operation and the denotions. There are so many set operations are there for morphological operations or for preparing the algorithms. So A subset B, A union B, A intersection B, disjoint of two functions, complement of A, difference of A and B, reflection of A, and the translation of set A by B. That is the set operations. And these are the practical examples of set operations. We can observe here figure A is a two sets of A and B. So here figure B is the A union B and the figure C is the A intersection B. And here is the D is the A complement. And the figure E is the A difference. A difference B. Already here we discussed A subset, A union, A intersection, disjoint of two functions, complement, differences of A and B, reflection of A, translation of A and B. Here also we are taking two sets of A and B and A union B, A intersection B and A complement B and A difference B. These are some examples of basic morphological set operations. And what are the reflections? Here we have to see here A reflection of B. Here A reflection, B reflection is in A reflection is in B. Here A and here B. Here logical operations of morphological set operations. First one is A. Here A, here not A not A or A not. Here background black, white is converted to black. Image object is black is converted to the white. Second one is A and B. Here A and B, A and B. Here A and B. So if I am intersecting these three things, what is a common thing? That is a blackish. And what are the not common things? That is in white. That is A or B. Here X or intersections. That is the what are the combining thing that I take as a white. So here not and gate means not A and B, not A this one and B. So we are adding these things plus A plus B, figure A plus figure B. It is a what are the common disjoint functions are there? That is a black, remaining is white. Okay, it is a logical operations of morphological operations of set operations. And another thing is a structure element. The small set of probe, the image under study is a structural element, and shape and size must be adapted to geometric properties for the objects. So here I am taking as it is a what is a common thing here means it is a common thing. So that is a structural element. Here 3 by 3 function. So middle point is a 5. It is a structural element. Here also middle point it is a structural element. Here also it is a structural element. Here 3 by 3 matrix. The center point is a structural element. And what are the basic ideas about this one is a S is a structural element. So where it is happened, okay. I kept here. So that means it is a structural element. That means it is a structural element. So what are these things are there? We are the structural elements. That is the A intersection B. And how to describe the structural element? It can be described in many different ways. First one is a information needed. How we get the information means position of the origin of structural element. First position we have to take. What is the origin? Suppose I'm taking x and y axis. What is the origin? This one. Okay, position of this one, and position of element belonging to SE. So what is the elements are there? So position of the elements. So position of origin, position of element, position of origin and position of element. These are the described in describing of SE. SE. SE means structural element. So there are the different types are there, shapes are there, line segment with structural element, line segment with origin of structural element, and the pairs of points, and structural element with line segmentation. And what are the major things of binary morphological operations are erosion, dilation, opening and closing, hit or miss transformations are the major binary morphological operations. It is one example of erosion, increasing to decreasing order. Dilation means decreasing to increasing order. Here increasing to decreasing. Combining of opening and closing. Okay, object and background. So any of that one. Suppose I'm taking any of the animal. If I'm taking any of that object, okay, it is the object. It is a background. So this object I'm calling as a opening. This background I'm calling as a closing. So erosion, dilation, combining, opening and closing are the very important roles of morphological algorithms. Okay, and some basic morphological algorithms are erosions here. Does the structural element is set, erosion of a set A by structuring element is B, A tends to B. That is the B union A. It is the erosion. Does the structural element fit the set? Erosion of a set A by structuring the element B, all are Z in A, such that B in Z. So if B equal to Z, A equal to Z, then B intersection of A. It is a one erosion, and it is one example of erosion. So it is one example. It is one example. So what are the common things are there? Suppose I'm taking here. Suppose here, how many pixels are there? How many are there? It is I'm taking 4 by 1, 2, 3, 4, 5. It is a 4. So 4 into 5, 4 rows and 5 columns, or 5 by 4, 5 rows are 4 into. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 into 4 I'm taking. So when I'm going for the erosion means what are the objects are there? We have to finding out the object elements. Okay, especially we are taking the object elements. Here I'm taking object elements. Here also another example. What are the object elements are there? We have to finding out with SE. Okay, and here I'm taking set A. Here square structuring element, square structure, and it is a figure C. Figure C, that is the erosion of A by B. And figure D, elongated structural element. SE is nothing but a structural element. So elongated SE, that is the structural element. So when I am going to the square in shape, what are the dividings are there? First one d by 8. Here to here I am taking as a d by 8. So this one to middle point 3d by 4. This one to ending that d by 8. So d by 8 to d by 8. Starting to ending is a d by 8. How we are dividing means d by 8, 3d by 4 or d by 8. So here d by 8 and d by 8. What is the middle one is a 3d by 4. Okay, it is a intersection of B, A erosion or A along of B. Okay, so every SE, this is I'm taking as a d by 4 in width and height. D by 4 in width and height. That is a structural element. And these are the one using of erosion to remove image components. A 486 into 486 binary image of a wire bond mask. B to D are the image eroded using square structuring element of sizes 11 into 11, 15 into 15 and 45 into 45 respectively. The element of the structural elements were all ones. So this figure is about erosion, using erosion to remove the image components. So in the figure A, what is happening here? In the figure A, 486 into 486 image of a wire bond mask. 486 into 486. You can observe here, there are some wires. It is like a wires. Okay, some wires are there. So in the figure B, B to D, what is happening means, so when I'm going to the B to D, B, C, D, the image is eroded using square structuring. The image is eroded using square structuring element of size 11 into 11, 11 into 11 and 15 into 15 and 45 into 45. So these erosions, what is the erosion here? We have to like this, okay, increasing to decreasing, increasing to decreasing means 14 of size is converting into the 24, 25 size, okay, decreasing, increasing to decreasing order. Like this here also, the using the erosion to remove the image components, A 486 into 486 is the original image, but B, C, D, we are reducing the mask, wire bound mask, that is the image eroded using elements of size 11 into 11, 15 into 15 and 45 into 45. We are taking some mask, applying the mask to the original image with 11 by 11 size of mask, 15 by 15 size of mask and 45 to 45 size of mask. When the size of mask is increasing, then the background is, you can observe here, the blackish is there, completely black. So we are not using any of the lines. It is not showing any lines here. Lines are disabled. All lines are disabled in the background. So you can observe here, only background is empty, only blackish. Why? Because mask value is increasing. Here mask value is decreased somewhat, some, not completely. These lines are removed here. You can see here, there are no lines are there. Here somewhat it is showing, but it is when I going the 45 into 45 mask, completely the mask size, completely background whitish colors are closed. Why? Because the mask is applied. So it is a basic morphological algorithm. So in the image compression, there are two types are there: error free and errorless, or error free means lossless and error free means lossy compressions are there. So compressions are two types, that is a lossy compression and lossless compression. So when I'm going for the data compression methods, these are two types are there: lossless methods and the lossy methods. In the lossless, text or program. In the lossy methods, image, video and audio is there. In the lossless, three types are there: run length, Hoffman and Lempel. And lossy means JPEG, MPEG and MP3. So these are the lossy. So what are the lossy and lossless? These are the key points of lossy and lossless. So lossless compression and lossy compression, data elimination, restoration, and quality. In the lossy, the quality is not good. Here the quality is good. Here restoration is not possible. Here restoration is possible. Here data elimination is there. Here no data elimination. So size is very less, size is increasing, and algorithms are used here. Yes, we are using some algorithms. Here also we are using algorithms, but uses are there. Audio, video, images are the uses of lossy, and lossless means text program codes. And what is the capacity is decreased. Here capacity is increasing. Why? Because the data is lost, the capacity is reduced. The data is not lost means the capacity is very high. So what are the major things of data is that lossless data is there, no loss of data. Here the data loss is there, and restoration is available. There is no restoration, and lossless data algorithms are there. Here there is no algorithms are there, and lossless compression is mainly used to compress text. Here there is no data compressions are there. If compression is needed, that maybe the data loss will be there. And compared to lossy data compression, lossless is a compression holds more data. Here we are compressing the less data, and file quality is high. Here file quality is low. And what are the images? Excel examples are there: raw, BMP, PNG, and ALAC files. Here MP3, MP4, and GIF files are there in the lossy data compressions. So these are about the error-free images and errorless images, and some basic morphological algorithms. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.